Hello all, today in this video I'm going to make an demo video for gradient boost with email spam detection dataset. This is a continuation video only. Previously with the same dataset we have worked with some other different machine learning algorithms and we have made an comparison. In this work also we are going to work with the gradient boost machine learning algorithm, and then we are going to make the comparison with the other machine learning algorithms we have made. For that, the dataset we have downloaded from Kaggle. The dataset you can just search as email spam detection dataset. Kaggle means you can get this dataset. That dataset is having nearly three entries. First is the serial number, which is the unnamed one. Next is email text, and next is email type, having two entries like safe email and phishing email. Then we are getting the info of the data set. From that you may notice that the integer unnamed one, which is the integer type, and all others, which is email text and email type, or object one. Then we are checking whether our data set is having any null values. You may notice that the unnamed one is the email text is having some null values of 16 types, so we have to drop it. And also the unnamed one, it's just an serial number, so we no need, so we can drop that also. So for that we are using the drop now function and drop duplicates, and again we are checking the missing values. If now you notice, means now we have omitted the unnamed entry, and also we have dropped the entry which is having the null values. Then we are getting the shape of the data set. We are having nearly 17,000 entries, and then we are making a plot with the safe email and phishing email within the email type to check that which type is having most entries. Among that we come to know that safe email is having most entries when compared to this phishing email. Then we are determining the x variable and y variable. Within the x variable we are calling the email text, and within the y variable we are calling the email type. Then by using this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. And by the use of the train test split function, we are determining variables like x train, x test, y train and y test. Then we are using the vectorizer. Why? Because the data within our data set is in text type, we have to convert it into vectors. For that we are using vectorizer. The vectorizer used in this work is tfidf vectorizer with the max features of 1500. This vectorizer we are applying to the variables like xtrain and xtest, and this xtrain and xtest variable only we are using in the every models. First we have worked with the logistic regression, and we have displayed the predictions, then the confusion matrix, and also the classification report, and we have got an 97% accuracy with this logistic regression. Then we worked with support vector mission and displayed the prediction, confusion matrix and the classification report, and have got a 98% accuracy with support vector mission. Then we worked with the catboost classifier and displayed the prediction, confusion matrix and classification report, and have got nearly 97% accuracy. Then we worked with passive aggressive classifier and displayed the predictions, confusion matrix and classification report, and have got a 97% accuracy. Then we worked with the random forest and displayed the prediction, confusion matrix and classification report, and has got nearly 97% accuracy. Then we worked with the naive Bayes and displayed the prediction, confusion matrix, and have got nearly 95% accuracy within the classification report. Then we worked with the KNN and displayed the prediction, confusion matrix and classification report, and has got nearly 69% accuracy. Then we worked with the decision tree and displayed the prediction, confusion matrix and classification report, and have got nearly 91% accuracy. Then in this code, we are working with the gradient boost. For that, we are initially importing the library which we are needed, and based on that library, we are determining a function. That function we are using for training, which is done by use of the fit function and the train variables. And then that function is also used for testing with the predict function and the testing variables. And then we are displaying the prediction variables within an array, and then we are also displaying a confusion matrix. You may notice that previously our data set is having nearly 17,000 entries, but here the confusion matrix is having only less values. This is due to the only 20% of data is used in testing, and the confusion matrix is plotted by using the testing variables. And also when coming to this classification report, it is also plotted with the testing variable. So here we have got nearly 94% accuracy, and we have made a comparison graph with the logistic regression, support vector mission, catboost, passive aggressive classifier, random forest, naive Bayes, KNN, decision tree, and this Gaussian Bayes, the gradient boost algorithm. So among that, you may notice that SVM is the one which is providing better accuracy of 98, and then three models like logistic regression, catboost, and random forest is providing better results with a 97. Then comes the passive aggressive regress classifier with 96% accuracy. Then comes the naive Bayes with 95% accuracy. The KNN is the one which is showing the less accuracy of 72%. So now which we have done comes after random forest, sorry, naive Bayes. So we have made a bar plot regarding that. You can see the bar plot here. KNN is the one which is showing least, and this SVM is the one which is showing the highest accuracy. 94 is it is not best and it is not lower. So in the next video we will be working with the ADA boost and will make a comparison regarding that. Thank you.